So you got to be careful here when you're putting this new cap in that you get that polarity correct. So in this case, I'm going to go here, and I have to do the same thing. So I want to go as close as I can to this end, so I leave myself enough lead. And then I'm going to do the same thing that they did, is I'm going to mark it here for myself. So I leave myself enough lead there. And then got the value exposed. And I want to go there. And then, like before, I want to tie that back in there. So I'll just eyeball this. Now you can see I have a full mechanical lock on there. That's the bias cap installed. Looking pretty good. Well, let's see now what we get. The next thing that we have done is we replaced that bias cap. And I also discovered that there was the grounding that was happening against that lug and this standoff. So at any rate, let's see what we get. Clean. All right, so no more big buzz. The next thing we want to do here is we want to get rid of this 150 ohm 7 watt resistor and this 150 ohm 7 watt resistor, as well as these 2000 picofarad caps. This resistor has to go, this resistor has to go, that cap has to go, that cap has to go, and they just literally need to be taken out of there. And then these 4 resistors have to be replaced. There's also a cap right here. You can see it. There it is, 5 microfarad. So let's take a look here. So this is a 5 microfarad, and that's right here. So this particular cap has to come off also. See that right there? That's out here. Why? Because if we look at the, first off, let's just look at the AB165. On the AB165, we can see that none of that exists here. And then if we go to the AA864, which is our final destination for this amplifier, Again, you can see that none of this exists here. At any rate, so you can see this is one of the ones that got to go. So for the moment, what I'm going to do is I'm just going to cut that lead here and leave it a little bit long on this end so I have something to grab onto when I go to pull it off. Do the same thing here. That's out of here, not useful to me to try to save those. Alright, I'll clean up these a little bit later, but for the moment we're just going to cut these puppies right out of there, get them out of our way. So those guys are out of there. This guy has to come out of here as well. So I'm going to cut that a little bit shorter. Alright, that's out of here. So let's take a look at what he sent. Now, the important thing is that these resistors are within a small tolerance of each other. You're going to get the best results when they're basically matched. So let's look at the 470s first. So yellow, purple, brown. See what we got. 466.7, somewhere in there. 466, almost 467. Pretty good. Let's check the other one. Spot on. Look at that. So that's something special there. They were able to match them that well. They're spot on the money. I mean, they're both 466.8 and 0.9. I mean, that's really accurate. So that's definitely nice of them to make that matched pair there. Is just put a little bit of cloth protectant on both sides. Neither one of those leads are touching this particular resistor, and I'm just getting it off center from where the heat would rise up. This, I'll make this shape right here, this particular resistor, and then put that through both leads, through both eyelets, and then give them a little bit of mechanical hook like that on both sides, and then solder that in place. Make sure to completely fill those eyelets as well. That adds more strength, believe it or not, to the circuit, to the joint rather. There's a little bit of an art to doing that as well, because you even can see from the factory often where on a lot of these eyelets they put too much solder. They're trying to fill that hole, and the solder actually just builds up with the base of the eyelet, and that's incorrect as well. So at any rate, this one is done. All right, so what have we done so far? We've gone into the doghouse and we have replaced the 6 electrolytics here. But how do you know where those are in comparison to the schematic and in comparison to the instructions that were received? So for instance, if we see this 8 UF, or in this case we print in a 16, that's actually right over here. You can see there's a 27K resistor there. That's this 27K here. And in between the 27K and the 4.7K, which the 4.7K is here, in between these two, we have another 20 microfarad here, electrolytic. Moving on, we have a 4.7K and a 1K, 4.7K, 1K. This is the electrolytic. That's right in between here. So forth and so on. You can see the 270 UFs are here. And then their 220K resistors, which are not featured on this diagram, are these two right here. So I have replaced all of these along with those electrolytics. This is how they lay out in the circuit. And then the flip side, if we were to look back at this and see that we have a black grounding wire here, a black grounding wire here, we have a red, a yellow, a brown, a blue, and barely you can see it in here, a white one here. Where are those wires in the circuit going to? So let's take a look here. So here we can see that black grounding wire. That's going to be this one right here. You can see the white one going through the grommet as well. Then you can see that blue one just right here. There's the blue one. So that blue one comes down to 100K resistor. Well, how do we know if we're being accurate? Well, let's take a look. Which is that blue wire? If we look at the diagram, we see that blue wire is halfway between 4.7K and the 27K connecting here. So the positive side, the ground side is connected. The positive side is connected here. So if we look here, halfway in between that point, we can see that between the 27K and the 4.7K, that electrolytic, of course, is connected to ground, but then it comes all the way up to, guess what? 100K resistor. So you can follow that line, say, oh, look, there's my 100K resistor, which is here, and then that continuously goes on and ties into this 7025 right here. So that's one way of telling where your wires go, and you can find it on your circuit diagram. Additionally, we have the brown, black, red, and yellow wires here, and those are here. So you've got the second grommet with the black, red, yellow, brown. And those you can follow. So for instance, follow the black one. Where does it go? It goes to the ground. So you can follow the circuit comparing as you go. These are not complex circuits. This is the most simple circuit you could ever work on because everything is laid out. There's no hidden anything. There's not 4 layers of PCB board with devices all over the place and SMD work. I mean, this is as basic as it gets. So pretty easy to learn on if you're going to try to learn electronics, but also on the flip side of that, also the most dangerous. So you want to make sure that you have taken all the precautions when you're working on a circuit like this, that your caps are discharged, that nothing's plugged in, the amp's not plugged in when you're working on it, and you know what you're doing. All right, so the next thing that we did here is we took out and removed these original 250 ohm 7 watt resistors, as well as these 2000 picofarad caps. Where are those in the circuitry? Those are actually here. So I'll bring that in a little closer. You can see the 250 ohm 7 watt resistors here, and then you can see the 2000 picofarad caps. So those are gone, and that is indicative of not existing in the AA864 that we're shooting for. Additionally, we replaced the 470 ohm screen grid resistors here, as well as the grid stoppers, the 1.5K here. And now you can see those in the circuit here. So there's the 470 ohm and the 1.5K, and that's been done on both. What's not on the schematic is this little 1 ohm quarter watt resistor that I'm using for biasing later, and you guys will see what that's about. All right, so the very next step is to get into the nitty-gritty for replacing my AC568/AB165 to make it a true AA864 style conversion using vintage Fender Repair.com's instructions. So if we come down to this section here, we'll see that they do tell us to replace that resistor that's sitting on the bias board. Now, typically there would be a 470 ohm resistor in there, and that's what we have to actually take out and replace in my case, because I, having a AC568, have a 1K resistor in there. Can you see that? So that's got to go. Good or bad, doesn't matter. And if we actually had an AB165, for the AB165, it is a 470. And of course, for the 864 that we're shooting for, it is a 470. So if we look at my bias board, here we can clearly see that it's a 1K. So that's got to come out, and I'm going to put that 470 they sent in the kit in there. Okay, as you can see, I have replaced the 470 ohm resistor as instructed to do here. We had a 1 watt resistor in there because of this particular circuit design. That's out of here because we wanted to get more like the AA864. We've swapped it out to the 470. Additionally, this cap right here, I'm going to leave in as the 100 UF 100 volt for now, even though they did supply a 4700, and that's going to just be my prerogative of what I want to see for the bias cap for this point. I may later change it out depending on what we see in the results, but for right now, that's finished with that section. So moving on, the very next thing that we're going to do is number 3 here. So it says locate the bias pot. This is a little pot with the screwdriver. Of course, it's this guy here, we know. So this time we can use diagrams side by side. We can have a look. So you can see here that there are two 10K resistors on the 165. So it's the same with the 568, but no one has made a diagram for the 568. Maybe it's a task I'll take on someday. At any rate, you can see there's a 15K resistor that are the same. This is a 10K linear pot. And then these resistors have to go, this array right here. So we'll pull those out of there, and then we'll come straight in to emulate the AA864 here. We'll come straight in from the center pin of the potentiometer, and we'll come down to this point here. All right, so we'll try to break this down a little bit easier. So you got to remember that vintage Fender amp repair is looking at this through the eyes of an AB165 to AA864 style conversion. Well, in this particular amplifier, we have an AB165 circuit, but we sort of also have, and most definitely have rather, the AC568. So we have kind of 3 tiers we have to look at for certain parts of the circuitry to gain the final result here of the AA864. So with that, the instructions here say remove both 10K resistors and remove the 220K resistor. But on the AB165, again, that lens, you can see the two 10K resistors are here. Here's that 220K resistor they're talking about. Well, we don't have that on the 568. We do have the two 10Ks, but we have a 100K resistor. Look here. So here you can see, here's the two 10Ks, and there's the 100. So if you're working on an AC568, again, this lens that they're looking through can get you to both, but you have to use a little common sense and use the circuit in which you're in. Now, if somebody was in here and they made mods that weren't in either one of these, you would have to use some common sense to say, what's my final result? And identify which resistor, where you have to make that change. Conversely, these are both 0.47 microfarad caps. And this particular lens, again, they're talking about the 0.22 or 0.047 capacitors. So depending on your model. In our case, the AC568, you can see that we have 0.47, 0.47. So I don't have 22s. So these are those caps that have to get replaced. So we'll do all of this in quick time. So furthermore, a neat thing that they've done here is they show us the actual detailed layout of the 165 and then what we're actually after later with the 864. So you can see all these items that have to get removed, and then you can see that here there's just going to be one wire, and then these resistors have to change. You can notice that these are 100Ks, and then goes to 182 over here. So those will be changes. But again, I have a little different layout because I don't actually have a 165. I have the 568. So there's going to be a number of wires here that are connected, and they're going to add a little tension to this board, this turret board. And what you got to do is just gently lift it up, and it gives you a chance to see how good your connections are. If something breaks, hey, clean it up, resolder it. So something also to take note of is that the This yellow wire here that runs to pin 1 on the 6L6 on this side comes through this eyelet, and that's where it homes. The red one attaches here. So don't lose those in track of moving all of this. You can see how that wasn't in there very good, so I got to change that. But we're changing these 3 resistors anyway. You can see that we have to make this section here inside of here. So you can almost see the layout before you, right? 220s, the 100K, the 82K, and then across these the 0.1 microfarad caps with the foil side facing this end. So just to double check myself, as we look at the AA864, we can see, let me back this out just a little bit. We can see the yellow wire running here, which is this one here, running from pin 1 underneath the board and into this eyelet here. So that's important. And I had to bend that back in there. And then from pin 1, the red wire running here, and in this case the red is the same as the diagram, that runs here. So that's great. But we got to remember that there's a little tiny bit of wire here from this guy, and that is our center of our bias pot coming into this hole and running to the center here. So that's important. So we're just talking about this section here by itself for the moment. And don't forget that from here there's supposed to be a brown wire running, and that's this guy here. So that has to sit inside here. That's this brown wire here. See that coming from the transformer? And then here's the 282 and the, let's take a look here. What are they? They are 100K and 82K. Right here you can see the gray of the 82s. They actually have to go this way. Oop, actually have to go this way in the circuit. Do yourself a favor if you notice how they got these paired here. When you take off this little bit of masking tape, clean that up with some contact cleaner. If you're going to use the full lead or cut it, make sure that the adhesive is off of there. So I actually get my finger underneath there and I bend those leads over. Same thing here. You can feel where I got to bend those. So those, all of them actually have some bent mechanical rigidity in there now. Again, you can see that little bit of wire that's coming through there. That's the red wire, that's the yellow one. So we got to do the same thing here. Get that guy in there without disturbing that other wire too much. Same thing, I'm bending those underneath so we have mechanical lock. So if you're wondering what my length is, I come 1/4 inch beyond the body of the device, roughly, right? I'm not trying to get too specific with these, but 1/4 inch. Why? Because I'm bending them over, I'm not letting them just stick straight through. Go. Everything's bent over and solid. That looks pretty good. Now we got to remember that brown wire here sits down in that hole there. So of course, if you want to verify, you can give yourself a little continuity check. So we'll say I want to check this to be sure that I got this wire touching this side here. Did it fall out of there? Probably not, but I'm going to just go one side of the resistor. Yeah, other side of that resistor. So I know that it's in there for sure. I can do the same thing to verify that I get connection with the red wire here back to pin 1. I come on pin 1 to the bottom here and here. Good, and nothing here. So pin 1 here. So you can see my flux is stopping my lead from actually making contact on there. But when I'm here and I touch, you can see. I got to clean that flux off yet. Conversely, we could just confirm this, even though we can visually see it's in there. If I wanted to just check my connection to be sure, 100%. And again, all of those leads that are in there are now bent underneath, mechanical lock as well as solder lock. And as the life of this amp goes on and vibrations happen, those solder joints aren't breaking anytime soon. All right, so if your brain isn't fried enough at this point, I'll try to make this a little easier and slow it down for you. So the 2 resistors here have been changed out. Those 2 resistors were my 247Ks here. And if you have the 165, that would be the 2 100Ks here. Likewise, the 22 that was here, if you have the 220 rather, if you have the AB165 was here, I had the 100K here, if you might recall from the last shot. So there's the 100K. And I had 247 caps here. If you got the 165, you've got 222 caps. And then I've replaced them now to match the 864, and the 864 has the 0.1 UF right here and right here. We verified also that the center wiper from the pot is here, and that is that little yellow wire right here that runs to the line. And then this brown wire here, if we look at it, that would be this line here. This would be the brown wire that runs down and out to our doghouse capacitor that has the now 22 microfarad cap going to ground. So that's where that goes, and that's where that's at on this particular circuit. Now we're down to this section, and here's the great thing is we did all of that, and then now they have a lovely statement that I really value here. It says, now here's where things get a little tricky. Ha! Good job. To be sure to study before and after diagrams for the next part, you will be doing a good bit of rewiring and part swapping. Don't get intimidated. If you do this a little bit, like I broke it down just because I'm trying to make this easy for you guys, rather than doing what I would do in the past as if I was in a time constraint, literally just wipe it all out, grab my new schematic and just build it in accordance to that. Well, when you've been doing this for a while, you can get away with things like that, but when you're trying to do something very fine and do it properly, it's very advisable to go step by step. So if you break it down easily like this, you won't have any problems at the end. Double, triple check your work. So the next section that we're going to work on is going to be right in here. That's going to involve these 3 caps, these 3 resistors down here, this resistor up here. We're going to have to make some wire changes, so we'll be doing that in the next shot. Okay, so in this next section, after the mandatory coffee break, it says here, they find it easiest, this is Mike talking actually, I find it easiest to first remove all 3 of the 0.1 caps seen in the top diagram. So what he's referring to are these 3 caps right here. 1, 2, 3. And in the case of the 568, that's 1, 2, 3. Now that happens to be identical for the AB165 as well, and so there's no difference in this particular section. So if we look at the AC568 circuit that we're working on, you'll see here that there are the 2 1 meg resistors and the 470 in the middle. Same thing on the 165, 2 1 megs, 470 in the middle, and then the 22K at the top, 22K at the top. So this portion of the circuit between these two is identical as far as I can tell. Yeah. So should just be able to follow along as instructions for the AB165 as they have written here, and you should get the same result. So they want us to first remove these 3 caps. So if you're following along, do yourself a favor, and the caps that you're in, resistors that you're putting in, get them laid out. You can even, if you want, lay them out in the configuration that they're going to go in physically. You could, some people, some amateurs can make some little cardboard I've seen people do, and then they'll pop resistors in there, and they'll make this shape and then set it off to the side and replace one at a time. Hey, if that's what works for you, go for it. I think that's probably pretty good. Keeping track of all these things. Okay, so there's something else that we got to cover here. Once you remove the 22K resistor and the 47K resistor, this being the 47, the 22 you can just barely see under there. I'll show this again once I remove these 3 caps. You then have to be careful to remove the underboard wire that runs from the extension speaker jack to the 47K resistor you just removed. This is the negative feedback loop. Keep the one end of the wire connected to the external speaker jack. So they're talking about this wire right here that runs right into the board. And if you follow this wire, it goes right to the external speaker jack section. So this is the one they were talking about. Remove that for the moment. So let's get that done. Because I know that I'm removing this cap anyway, while we're here, we'll just get it right out of my way. So I thought I would point out that we were talking about a little bit of another difference between the AC568 and the 165. And here we can see that there is a 47K ohm resistor with a 100 picofarad ceramic cap across. That's this part of the circuit. I'll highlight that. The AC568. On the 165, it is in series with that 0.1 cap, 47. So if you have a 165, you can be looking for that without the 100 picofarad cap. So that's that resistor right here for the negative feedback line. As you can see, it's the negative feedback circuit here. So with that being said, that negative feedback resistor for the AA864 that we're going for has an 820 ohm resistor and that cap removed. So you can see here's the 820 ohm resistor, this cap removed, indicative to the 568, but this other 1 microfarad cap here, that's out of here. On this particular circuit, you can see that it's gone. So when we add caps, we're only putting 2 caps back. We took out 3, adding 2. All right, well, here's where things can get a little confusing for some folks. Let me try to make this clear for you. So what I'm going to do is just try to zoom in here a little bit. We can see on the instructions it says signal input from preamp, keep this wire in place, with a little asterisk sign in a sense that they've made here. That's this point right here. Now it may not look quite like it if you look at the layout and the shape here. This is a close depiction of this, but it's not exact. If we look here, this point is this point, then this goes to ground. So the wires that have to be removed in the directions where they talk about carefully remove the underboard wire that runs from the extension speaker jack to the 47K resistor you just removed. That's this wire here that runs here and that was running underneath, and then that goes to the 47K, which was here. We're going to pull this wire out, relocate it here, and then we're going to add in our 820 ohm resistor and tie that back to this point. The other wire that has to be removed is this wire here. And that wire, you can see the end of it sticking out here, and then the other side terminates here. Here, I can actually prove that to you. Let's take a look. Or you can take my word for it, but either way. So we're looking for this wire here. to have continuity to that point. So if I see that wire, I see it right there. There's our continuity. So it's certainly not this one. This one is the signal one. Now, if we want to verify that the one that's going here for the negative feedback, which is here, the extension speaker, should be here. There it is. So I think I can make that clear. I'll go over it one more time. So this wire here is coming out. It's currently here and here. It's coming out and it's going to get redirected into here. I'll cut it, shorten it, and stick the wire back up through. And then we'll add the 820 ohm resistor there, tie it back to this point, and then we'll remove this wire here, which currently goes from here to here. And the entire time you can see the little bit of nub sticking out there. That's the signal wire. That has to remain. You can see that's still here in this particular layout. So let's just get that portion done before we do anything else. So I'm looking to get this one out of here now. That's this guy, and that should be this guy. There it is. And of course it won't be that easy to do. Try to guide it through without putting too much pressure on it, anything. There it is. All right, so that's coming off the speaker jack, so that's good. So now we got to get this wire out, so we'll do the same thing here. Push that through and get my finger back in there to feel it. And then we should be able to pull it through here. There she is. Now I can feel it's caught. It's caught under the signal wire here. And there we go, finally. Woohoo! Oh, I thought all that was being filmed. Guess I missed the shot there. Anyway, so that came out of there, and then here's the signal wire. Well, that's what we were after to remove. That's the wire that came from here. You can see it. It came from here to here. That wire's out of there. And now our signal wire, which is here, has to remain inside of here. So I gotta get that puppy to come back through here. And oh boy, did I get lucky, huh? Let's see. I think I can see it. Yeah, there she is. So now that's gonna stay there, and then I gotta feed my ground wire, which is here, back through there. Then what I can do is I can bend this guy over just a smidgen like that, pull this back. I can get these guys to go back down in there. But I think I'd like to clean that up just a little bit more with some solder wick. What I'm going to do now, because that's very dry, I'm just going to add a little bit of flux on that. And that little bit of flux, believe it or not, coupled with the solder wick, will make a little bit of a difference here. Get that last little bit out of there that I want. There it is. Now I got a nice clean eyelet to work with. So be careful here. You can see there's a 0.001 UF cap, then a 0.1 UF. So if we look right here, you can see there's 0.1 and then 0.001. So you got to be careful of that. One other thing to notice here, if we're talking about wires, is there's a little sneaky wire right here that remains. You see that? That remains. You can just see that sticking out of the hole right here, but that has to stay. So as you're putting these in there, you can think about where you want your leads to bend. And if you're real careful about it, you can get them pretty exact where there's really no pressure back on the device, right? Or back on the component, rather. Dropped in there rather easy like that. And then what I do, again, different than what you might do, is I bend them over with my finger. And if you can't, you can also use a little bit of a tool. Like sometimes I'll use this one. I'll try to feel where the leads are, go sideways, and use that to kind of rake them over. There we go. Now I know those aren't coming out of there. So that's just one little thing that I do. Doesn't necessarily mean you need to do that. But different techs have different ideas, and that's my idea at any rate. You know, just having a little pride in your work, spending a little more time on doing those sorts of things can make for longevity in the device and longevity in your employment. You get a good reputation, right? Doing things the appropriate way. Or hey, you know, when I get things back from that guy, I don't got to return them too often. They don't fail too often. You know, that's the kind of things you want folks saying about you. So those are important things to me. All right, so moving on here. So far we have the 820. Let's put it on this side. We have the 820 here in. We have the 1 microfarad, and then we have the 1 meg here, the 470 ohm here, the other 1 meg here. This little sneaky wire is still connected, and if you're unsure of that, just do a continuity check. Yeah, still good. What do we got next now? So next we have this 100 ohm resistor that's going to go from this point here over to this point here. And then I can't fit anything more in that hole. Those are 2 other resistors that are down there, plus these 2 caps and that grounding wire. So I'm going to have to actually wrap that one around. Not my preference, but it'll solder on anyway. But I will physically wrap it around. And then after that, we've got the last cap to go right here. Another thing you might notice as well is you try to put all the resistors facing the same way so the values are up. They did that at the factory, and you can do that as a courtesy to the next guy if he's got to go in there and troubleshoot real quick. You can look at the color coding, and if they're all facing the same way, it's a lot quicker to the eye. So we're ready to seize this point here in the center, and I'm going to do that. There we go, got that bent over. So now we'll seize that corner. Every time you do this, one thing that you can think about is making sure that the eyelet is getting touched by the soldering iron, because that's the heaviest piece of metal that you got to deal with, right? Now here's where that wire runs. It's still in there, as you can see. Yeah. I'm going to rise it up just a hair, because what I don't want is I don't want any heat getting on that body at all during the soldering process, right? So what could end up happening, I don't think you can see it from up there, is that capacitor body could be sitting on that eyelet, and if you go ahead and heat that up, you could burn through this coating on the outside. There you could damage your cap. So you got to be real cautious about how you approach where you put your iron and so forth, and that you don't touch the body of that cap whatsoever, or you're going to be replacing that cap. And try not to let too much heat get inside as the solder cools, so you can grab the lead with a set of tweezers or whatever, and it's just some sort of heat sink. Okay, so we're almost done with this process. So as a recap, pun intended, let's go down and see what we've done so far in this section. So if we look at A, it says remove the initial 3 caps. So we've done those 3 caps that look much like this. We've removed those from here. B, look at the right side of the circuit board. You will see the 1 meg resistors and the 470K. Replace those. So these 3 have been replaced. C, remove the 22K and the 47K and carefully remove the underboard wire that runs here. So we've done that. Hook that back up to the 820, which is D. And then we ran a new 22K resistor from the junction of the 470 ohm, which is here. That's this resistor here. And install a new 0.1 capacitor at the same junction, the 820 ohm and 22K. So here, this guy right here. And then F is, it says at the 820 22K 0.1 junction, which is here. You can see all that happiness right there. Add a new 100 ohm, which is this guy right here. And connect the other end to ground via the eyelet to the right with the 1.5K resistor and the 25 UF caps. That's this section here. That's the point they're talking about. Okay, so additionally, it says important. There is a wire that runs under the board from this eyelet ground connection to the now empty eyelet that connects the old 0.1 and 22K just above the M. You must remove this wire. So in the diagram, that was this wire here, 22 to the 0.1, and we have removed that, if you remember, in the last shot. So that was from here, and it went to there, and it's out of there. It's in the box. This one remains empty, nothing in it, as you can see here. So everything that you see there now is complete, including these caps, those resistors. Everything that is here is exactly like this is now. So this section we can consider done, except for one thing. On the following page, it tells us something you cannot forget. You cannot forget, and I'll put a little light on this so you can see. There's a green and black wire. I'm not sure if those will turn out in the camera. Green and black wire. Right now, the black one goes to the speaker out, and the green one goes to the extension speaker out. So those have to actually be reversed. So you can see here, he says, come on in a little bit further. Very important, take a look at the speaker jack and extension speaker jack. You will need to switch the green and black wires from the output transformer. Just put the green wire where the black used to be, the black where the green used to be. After the mod, the green wire should be on the speaker jack, and the black wire should be on the extension speaker. So that's easy. So I'll do that now. The green one is now on the normal speaker jack, and the black one is on the extension. And so while we're here, we know for sure, I'm going to turn this back on. We know for sure that no matter what we do, we have got to replace these caps. They're definitely leaky by now, and we got to make sure, we got to get them out of there. So these electrolytics that we knew we had to change are done. This section for the conversion is done.